This is SpaceTime, Series 29, Episode 12, for broadcast on the 28th of January 2026. Coming up on SpaceTime, continents deep inside the Earth's mantle, confirmation that the red planet Mars was once a blue planet, and a new study has discovered how galaxies can grow quickly by sucking in filaments of cool gas to feed growing stars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists studying the evolution of two massive continent-sized regions in the Earth's deep mantle have now discovered that they each have their own very distinctive histories and chemical composition. The findings, published in the journal Scientific Reports, contradicts the previously held assumptions that they're both basically the same. Seismologists have long known that seismic waves generated by earthquakes do not travel through all parts of the Earth's interior at the same speed. Now, it was this principle which allowed them to visualize the inside of our planet, even at depths inaccessible to humans, using techniques similar to those employed in CT scans for medical imaging. Deep inside the mantle, that's the almost 3,000 kilometre thick layer between the Earth's molten iron outer core and its silica-dominated crust, there are vast areas beneath the Pacific Ocean and under the African continent where seismic waves travel much slower than average. These large low-velocity provinces are bigger than most continents, up to 900 kilometres in height and thousands of kilometres wide. Now, one common hypothesis is that they're made up of oceanic crust that is pushed deep into the mantle at subduction zones. The crustal material was then stirred through the mantle over millions of years and accumulated to form these large low-velocity provinces. Researchers have typically assumed that both large low-velocity provinces are similar to each other in nature, with the same chemical composition and age. That's because the seismic waves travel through both of them in similar ways. But now a new study has challenged this view by modelling the formation of these large low-velocity provinces through time. By combining a model of mantle convection, including how tectonic plates have moved over the Earth's surface over the last billion years, the study's been able to show that the African large low-velocity province consists of older and better mixed material than the Pacific large low-velocity province, which contains 50% more and much younger subducted oceanic crust and is therefore more different to that of the surrounding mantle. The resulting differences in density could also explain why the African large low-velocity province is more diffuse and taller than its Pacific counterpart. The study's lead author, James Panton from Cardiff University, says that because numerical simulations aren't perfect, he ran multiple models for a range of parameters, and each time he found that the Pacific large low-velocity province was enriched in subducted oceanic crust, implying that Earth's recent subduction history is driving this difference. The models of this study also show that the Pacific large low-velocity province is consistently being replenished with fresh oceanic crustal material for at least the last 300 million years. That's because it's surrounded at the surface by a circle of subduction zones known as the Pacific Ring of Fire. Now, by contrast, the African large low-velocity province doesn't receive any new material at the same rate, and so the material is mixed more with its surrounding mantle, lowering its density. Until now, these differences have all been overlooked. That's because temperature is the dominant control on how fast seismic waves move through a material. But the models presented in this study demonstrate that both large low-velocity provinces actually have the same temperature, which explains why they look seismically similar. The fact that these two large low-velocity provinces differ in composition but not in temperature is key to the story and explains why they appear to be the same seismically. Mind you, it's also fascinating to see the links between the movements of the plates on Earth's surface and structures 3,000 kilometres deep in our planet. The high temperatures of the large low-velocity provinces and their positioning in the deep mantle on each side of the planet means they also affect how heat is extracted from the Earth's core. This impacts convection in the outer core, a process that drives the planet's magnetic field, which in turn protects us and all life on the surface from the harmful effects of cosmic rays and solar activity. And when you think about it, it means that if the African and Pacific large low-velocity provinces were different, heat may no longer be extracted symmetrically, and that could lead to magnetic field instability. Not good news for any life on the planet's surface. So this makes it important to understand the structure of the large low-velocity provinces and how they influence heat extraction from the core. Scientists now need to account for this asymmetry in mantle density within their models of the deep Earth. This poses a challenge for observations, as the data that are being used often only provides information on symmetric structures within the Earth. They also need to look for data that can constrain the proposed asymmetry in density, for example by using observations of Earth's gravitational field. All in all, it's a fascinating look at how the Earth might have been so very different. This is SpaceTime. Still to come, confirmation that the red planet Mars was once a blue planet. And a new study has discovered how galaxies can grow quickly by sucking in filaments of cool gas to feed growing stars. All that and more still to come on SpaceTime. A new study examining ancient Martian river deltas is providing further proof that the red planet was once a blue planet with a vast ocean. The findings, reported in the journal MPJ Space Exploration, are based on the detection of structures on Mars that are very similar to classic river deltas seen here on Earth. These are traces of rivers that have deposited their sediments into an ocean, and they showed that Mars was once a blue planet around 3 billion years ago. The existence of vast quantities of water on Mars has been a central topic in planetary research for years. Previous studies have already shown evidence of oceans and rivers on Mars, indicating a once humid and possibly wet habitable environment, rather than the cold freeze-dried desert Mars is today. The latest evidence of former water and a possible river connection to an ocean were discovered in the Valles Marineris, the largest canyon system on the red planet, which stretches along the Martian equator like a giant rip in the crust. The study's authors gained new insights in the geological history of Valles Marineris using high-resolution images from a number of spacecraft orbiting the red planet. They found geomorphological structures near the canyon system that resemble river deltas on Earth. The study's lead author, Ignatius Agudestia from the University of Bern in Switzerland, says these unique high-resolution satellite images have enabled scientists to study the Martian landscape in great detail by surveying and mapping. Scarp-fronted deposits were discovered at the lower end of the canyon system, which are being interpreted as fan deltas. Fan deltas form where a fan-shaped cone of debris and sediments grows after flowing directly into a standing body of water. The authors found that these structures mapped on Mars are very similar to classic deltas on Earth, where rivers disgorge into oceans. While not the first to postulate the existence and size of the ocean, those earlier claims were all based on less precise data and partly on indirect arguments. On the other hand, this new reconstruction of the sea level is based on clear evidence for such coastlines, using the high-resolution images. As a result, the authors were able to provide clear evidence of the deepest and largest former ocean on Mars to date, an ocean that stretched right across the planet's northern hemisphere. Now today, wind-sculpted dunes cover the former delta structures. However, their original shape is still clearly recognizable. The authors say the discovery of deltas and the confirmation of evidence of a former ocean suggest that conditions once prevailed on the red planet that could have favored the emergence and development of life as we know it. This is SpaceTime. Still to come, a new study has discovered how galaxies can grow quickly by sucking in filaments of cool gas to feed growing stars. And later in the science report, discovery of the oldest known rock art in the world, dating back some 67,000 years. All that and more still to come on SpaceTime. This episode of SpaceTime is brought to you by Squarespace, the platform that makes building an incredible online presence not just possible, but effortless. Squarespace gives you all the tools you need to create a professional website, claim your perfect domain, promote your brand, and even get paid, all in one easy-to-use place. And here's where it gets really exciting. Squarespace's design tools give everyone the power to create a website that looks like it came from a top-tier design studio. Start with Blueprint A1, which asks a few simple questions about your business and goals, and then generates a custom site complete with design suggestions and content ideas. Or you can choose from their award-winning templates, and then easily tweak them with intuitive drag-on and drop editing, dynamic visual effects, and flexible styling options. The result is a website that is unmistakably yours, no coding or design degree required. Now, if you want to see how easy it is to bring your ideas to life online, visit squarespace.com/spacetime for a free trial. And when you're ready to launch, use the code SpaceTime at the checkout to save 10% on your first purchase for a website or domain. That's squarespace.com/spacetime, promo code SpaceTime, and of course we have a link in our show notes.
You're listening to SpaceTime with Stuart Gary.
A new study has discovered how galaxies can grow quickly by sucking in filaments of cool gas to feed growing stars. Apart from merging with other galaxies, individual galaxies grow by accumulating gas and dust from their surroundings and then converting that into stars. But the details of this process have remained somewhat murky. However, observations reported in the journal Nature Astronomy made using the Keck telescope's cosmic web imager provided clear direct evidence that filaments of cool gas were spiraling into young galaxies, supplying the fuel for star formation. The study's lead author, Christopher Martin from Caltech, says that these were the first observations showing filaments of gas directly spiraling into a galaxy. He describes it as being like a pipeline going straight in, sustaining star formation and explaining how galaxies can make stars on very fast timescales. For years now, astronomers have been debating exactly how gas makes its way to the centre of galaxies. Does it heat up dramatically as it collides with the surrounding hot gas? Or does it simply stream in along dense filaments, remaining relatively cold? Modern theory suggests the answer is probably a mix of both. But proving the existence of these cold streams of gas has remained a major challenge until now. After their initial observations on the cosmic web imager, the authors then used an integral field unit spectrograph, also attached to the Keck telescope, in order to take more high-resolution images, in which every pixel in the image contains its own dispersed spectrum of light. In fact, this amazing instrument has some 8 times the spatial resolution and 10 times the sensitivity of the cosmic web imager. The question of how galaxies and stars form out of a network of wispy filaments in space known as the cosmic web has long fascinated astronomers. To find the answers, Martin and colleagues acquired data from 2 active galaxies known as quasars, catalogued as UM287 and CSO38. But it wasn't the quasars themselves that the astronomers wanted to study. You see, nearby each of these 2 quasars was a giant nebula larger than the Milky Way, and clearly visible to the astronomers thanks to the strong illumination of the quasars themselves. By looking at light emitted by hydrogen in the nebulosities, specifically an atomic emission line known as the hydrogen Lyman alpha, they were able to map the velocity of the gas. Now, from previous observations at the Palomar Observatory in California, the authors already knew that there were signs of rotation within the nebulosities, but the Keck data revealed far more. Palomar allowed them to see what looked like a rotating disk of gas, but they couldn't make out any filaments. However, the new Keck data allowed the astronomers to develop more sophisticated models and see that these objects are being fed by gas flowing in from attached filaments, which is strong evidence that the cosmic web is connected to and fueling this disk. Martin and colleagues developed a mathematical model to explain the velocities they were seeing in the gas, and they then tested that on UM287 and CSO38, as well as on a computer-simulated galaxy. And the findings are providing the best evidence yet for the cold flow model of galaxy formation, which basically states that cold gas can flow directly into a forming galaxy, where it's then converted into stars. Before this model came into popularity, researchers had proposed that galaxies pull in gas and then heated it to extremely high temperatures. From there, the gas was thought to gradually cool down again, providing a steady but slow supply of fuel for star formation. But in 1996, researchers threw that model into question after it was shown that distant galaxies produce stars at very high rates, too fast to be accounted for by the slow settling and cooling of hot gas that was a favoured model for young galaxy fueling. One of the study's authors, Donald O'Sullivan, says the new findings provide the answer by showing how filaments of cold gas can stream into a galaxy, providing the fuel needed for star formation.
When you look at the sky, you see billions and billions of galaxies. And I think a very natural question to ask is, how did they get there? Why do they have the kind of shapes and sizes and colors that they do? And in order to be able to answer that question, you need to understand the environment they came from and the environment that they're growing with. And that is the cosmic web. The cosmic web is the gas between galaxies, the intergalactic medium. And we nickname it the cosmic web because it's spread out in what looks kind of like a spider web filamentary structure. What we are trying to do is make maps of the cosmic web. With Palomar, we looked at this gas, you see what looks like a disk, and you see that it's rotating, but our resolution was not great. Just enough to be able to say, we think that this is a giant disk of gas, 10 times the size of the Milky Way, and we think it's rotating. With KCWI, because of the increased sensitivity and the increased resolution, we were able to provide very strong evidence that we are directly observing filaments of gas connecting to this disk from the cosmic web, and look at how they changed its velocities and how they changed its morphology. And this has been predicted in theory and simulations, but never yet observed. Working on instrumentation at Caltech, it's incredible because you're building new ways of looking at the universe, which maybe weren't accessible before. I built a small part of Keck Cosmic Web Imager. Working with Chris Martin, you really get trusted with serious responsibilities to build important things. We want to achieve two things with the Cosmic Web Imager. We want to be able to look at spectroscopy, meaning the color of the light. We also want to get a full 2D image. Hydrogen emits at very specific colors. Helium emits at very specific colors. So the way we identify gas is by atomic emission. So you get an image where at every pixel, you also get a spectrum of light. In every pixel you say, is there hydrogen here? And you can make a map of that gas. One thing I'm really looking forward to with the Keck Cosmic Web Imager is that we're going to be able to collect a large sample of observations like this. Where one or two case studies is nice, what's really great is to be able to look at, tens or hundreds of objects and build up a big picture of how these processes work in the early universe and how galaxies form and evolve in a more statistical sense.
That's Donald O'Sullivan from Caltech. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Anthropologists have discovered the oldest known rock art in the world, dating back some 67,000 years in a cave on the Indonesian island of Sulawesi. The new findings, reported in the journal Nature, are some 1,100 years older than the previous record setter and 15,000 years older than cave art previously found by the same team in the same region. The authors say the findings advance science's understanding of how and when Australia first came to be settled, with the Sulawesi art very likely created by a population closely linked to the ancestors of Indigenous Australians. A new study suggested the power of the ancient Tethys Sea may have shaped Central Asia's topography during the Cretaceous period. The findings, reported in the journal Communications, Earth and Environment, are based on a big data approach that involved hundreds of thermal history models for Central Asia throughout 3 decades of research. The Tethys Sea was a vast prehistoric ocean that separated the supercontinents of Gondwana and Laurasia from the late Paleozoic through to the Cenozoic eras, acting as a major maritime highway for life before its closure formed today's Indian Ocean, Mediterranean Sea, and Eurasian inland seas. It was characterized by warm tropical conditions that fostered abundant marine life, including reef ecosystems, and significantly influenced global climate and ocean currents of the time. How now brown cow has taken a whole new meaning, with behavioural tests of a pet cow showing for the first time that cattle are capable of versatile tool use. A report in the journal Current Biology has shown how a bovine named Veronica could use a broom to scratch herself. The authors showed that she would pick up the broom and use the brush end to scratch areas like her back with forceful movements. And then she could turn the broom around and use the stick handle end more carefully for those sensitive areas like her udder. The authors say this is the first experimental verification of tools being used by a cow. But this capacity may well be more widespread, though unlike Veronica, cows in impoverished farm environments may not get the opportunity to show it. In fact, the findings show that livestock intelligence may have been severely underestimated due to gaps in our observation. Well, it's taken a long time, but Apple are finally planning to overhaul their aging intelligent virtual assistant Siri, transforming it into a chatbot similar to X's Grok, OpenAI's ChatGPT, and Google's Gemini. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Well, for the longest time, Apple has said that it wasn't interested in having a Siri GPT where it was a chatbot in the style of ChatGPT or Gemini. I mean, anybody can download those now and they can see what a great job those particular programs do. But in the last few weeks, we've had confirmation that Apple is going to have a white label version of Gemini. And they're going to supposedly still be running on Google servers, but running under its own private cloud compute infrastructure. So Google won't have access to what's being searched, what's being asked about, and Apple will maintain its privacy. Now, coming in March or April is meant to be iOS 26.4, which will have the beginnings of this more intelligent Siri. It won't have the chatbot yet. That's supposed to be coming in iOS 27 and previewed at the Worldwide Developer Conference in the middle of the year when Apple normally showcases what's coming next. But it is well over a year late with its version of Siri that can look at the apps that you're using, fish out information on who you met at the cafe 2 or 3 weeks ago when you were there, from SMS messages, from emails, from calendar appointments. And Apple will have access to its apps in a much deeper way than ChatGPT or Gemini themselves can have, because Apple's just not giving that sort of access to outside apps. And so, look, this has only just come out in the last day or so with Mark Gurman from Bloomberg, the unofficial spokesperson for Apple. He leaks all this information. He's obviously getting it from Apple, but clearly it's one of those things where they leak it to him and then everyone else talks about it, and that's how Apple gets a lot of its messages out without having an official launch. And there's also been news as well that Apple is working on an AirTag sized AI wearable with some cameras. Now, we have seen the Humane pin that had that sort of capability that failed a year or two ago, was beaming information into your hand via a laser, but it just didn't work very well. When I was at CES, Motorola, part of Lenovo, they also had a wearable, like necklace type of pin that, could listen to everything, and it had a camera so it could record things. And, then like these AI devices, it can memorize everything. It can give you notes, give you a transcript, tell you what you agreed to do, what the next steps are. And other companies are working on this as well. We've got OpenAI with Johnny Ive, the former Apple chief designer, working with Sam Altman from OpenAI to create some sort of an AI pin as well that is a screenless device. So there's a lot of people working on this. I mean, you can certainly imagine that someone like Apple is going to have the wherewithal to create this and stick by it and make sure that it really does respect privacy. Apple has been missing in this space. They have done a lot of things to try and make Siri better, but Siri is the worst of all of the AI systems at the moment. But, I'm very hopeful that in April we'll have 26.4 and it'll be much better. And then from about June, July this year, when they have WWDC, I'll be first to put it on one of my phones to test out this new Siri GPT chatbot. And hopefully it's as good as we would expect it to be.
That's Alex Zaharov-Reutt from TechAdvice.life. And this is SpaceTime. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.